Hello YouTube viewers, welcome to my channel Science to Technology. In today's explanation video of the expo, I'm taking a bit of different path because I have to travel somewhere again, maybe to another expo, so sorry about this. So I hope you have seen the Torus Axial Flux motor video. So basically this is a company in Chennai and they are focusing on making axial flux motor. Now if you know motors, you know they come in two topologies. One is radial flux. Basically, if you think of a motor, you are thinking of a radial flux. Basically, the spin is perpendicular to the magnetic field. Axial, it's literally parallel. Basically, this is how you're spinning and this is parallel it is. So basically how magnetic flux line travels, it's parallel to the shaft or 90 degrees. 90 degree is radial. Almost everything you think of is radial. And then we have axial flux. Now, ironic part is we used to make axial flux in the ancient time. And I mean time of the Nikola Tesla, Thomas Edison, those sort of time. We used to make axial flux. So axial flux does allow you to have better coupling, meaning you can make much higher power dense motor, meaning for same amount of horsepower or same amount of kilowatt, you can make it, like in this case, they are achieving 50% compact and lightweight. Another aspect is 95% efficiency. You can achieve very high efficiency with induction motor, specifically if it's copper rotor and air gap is much smaller. Basically that's the biggest loss, one of the biggest loss in induction motor. So in cheap motors the gap is huge because again it makes it easier to manufacture, but if you can make it tight, you can improve the performance. And if you are talking about industrial customer, they generally do not use induction motors, they use synchronous motors. Those could be brush or brushless. Those puppies are ludicrously efficient. The world record of motor efficiency is basically brushless AC synchronous motor. That is at, like, if I'm not mistaken, 99.13% efficiency. ABB made it. It's in India, somewhere near to Ahmedabad. So efficiency 95% is decent, like you're supposed to get that. If you're not getting that, you're doing something wrong. Air gap could be huge, or flux geometry may not be great. So why would anybody look into this? Well, this makes sense if you are talking about anything that is portable, aka anything that has to move. Now they do have diagram of a basically industrial plant. Would industrial plant look into this? Maybe, maybe not. It's there are some advantage of going into this, but not that much. Like again, because you have to understand that industrial customers play on a different scale, and if they know a synchronous motor can last forever, which again we have synchronous motor that has been lasting forever, and we have synchronous motor that can run without VFD. If you have a scenario where you just want a motor to start and spin, synchronous motor has the advantage that it's power factor of 1. No electronics, no hassle, power factor of 1. So axial flux motor makes sense where you need power density and where the weight saving actually makes an advantage, which is transport, which is electric vehicle, specifically anything that is constrained. For example, if you want to make a motorbike and you want a lot of horsepower, you don't have that much space for a big ass motor. In those sort of scenario, axial flux motor makes a lot of sense. So basically electric vehicle could really enjoy from axial flux motor. Now there are a lot of companies that are making axial flux motor. So what Torus is allowing is a complete package. So their special sauce, which they did not talk about in the system, I talked afterwards, is their stator is the made differently, meaning most times stators were made out of what we call silicon steel. You wrap them up like a donut, you keep wrapping up, and then you mill the path for your windings. Now it does work, but because you are basically, it's not stamp sheet though. Basically when you are going through with a drill bit or a milling bit, it is messing up that area. So basically you have almost milder shorting of those plates, which is again suboptimum. It's not end of the world, it does work. Again, that's why we have so many axial flux motor, but it's not great. And then somebody figured out how to have a basically strip of silicon steel, stamp it and keep rotating it. And again, the stamping machine could expand the gap, so all the stator slots line up. Perfect technology, awesome. But again, then you have another problem because that system is not perfectly radially aligned. So you have to do grinding on it to make it precise. Again, grinding also messes up that eddy current loops. So again, reduces a bit of quality. They are using a different kind of method, almost like a powdered metal that they are infusing to achieve similar property to silicon steel, basically minimizing eddy current loops and maintaining the air gap, meaning they have very high precision without having that milling side effects. So that's how that's their special sauce, and that's just one vector. Second is they're basically controller, and they're the only one I've seen which actually talk about motor control, because be mindful, this machine part, this whenever you're talking about the motor part, that's half of the equation. The other half is this motor driver, and they have very decent motor driver systems. And not only that they have motor driver, it's also configurable. It's not that whenever you are buying there are a lot of major manufacturers, like we have made hundreds of this, you want to tune it, like you want to reduce regen or increase regen, yeah, you can't really do that. So in this scenario, they're gonna work with you, and the product, the basically field oriented controller they have, allows you to tune parameters, which again, does that matter? Yes. Half of the time, whenever you're seeing electric vehicles getting update, that's what they are updating, is the tuning, mapping. Basically, like how engines have throttle mapping, you need something similar in electric vehicle. So having direct deep access control into the motor driver, it's good. And the fact that they actually spent time to have a GUI elements, as in graphical user interface, like it's not command line, it's like somebody put some effort into it, that's also useful. So they are not just a company that has axial flux, they have a company that has axial flux motor, that has bit of a superior stator with a motor driver that is far more customizable, configurable to bare basic systems. And they're gonna work with you, because this is a small company. They're gonna work with you. What do you need? Basically, we might again, fingers crossed, we might work with them for our upcoming Ahiravat engine for a motor generator unit, because again, at that point we need something that is perfect as a motor, perfect as a generator. Now the mechanical part, that's done, it does not care. But the motor driver has to switch. Most motor drivers, again, cheap ones, high-end one, car-end grade ones, those are designed for that. That's not an issue. But cheap ones are not. They have fine-tuned it, so they have basically something that we are looking for. So we might work with them. So all that being said, does that make axial flux the future? Well, while almost everything is good, there is one severe penalty with axial flux: bearings. Look into any motor rebuild. Most of the time what they are rebuilding is bearings. Unless you have a bad luck and you have electrical shorting, the only thing that is guaranteed to wear out is bearings. It will go bad. Let me be very clear. Bearing is consumable in motors. Like that's why, like bearing pullers and all that, like why do you think we invented, like why do you think bearings is a consumable item even in engine block when we have everything oil lubricated? Again, after a lot of kilometers, but it is. So axial flux, because you are shrinking the shaft, your wiggle room for the bearings goes down, and penalty bearing has to be extremely robust, and that's a bit more difficult than you realize, like really difficult than you realize. And not to mention, because you have a shaft and you have a plate like this, power here, if you're applying power here, it's torquing this system. Radial flux is far more not off-axis loading is much different. So fundamentally, bearing is something that you have to design for, work for, or you have to make sure that it's coupled in such a way that it has the wiggle room. That's why you will say flexible couplers and all that jazz. So let that be very clear. Axial flux is a good technology, really useful technology. However, if you have to deal with the scenario where you have to put a lot of stress load directly going through the motor, maybe look into radial flux. And again, that's the reason why many electric vehicles are still using radial flux, because that's the easiest way to make sure that bearings do not go kaput. Bearing is the victim, because again, ask any mechanical engineer who deals with bearings and all that, is like, okay, I have a shaft that is this long and I have this much room for bearings, versus I have a shaft that is half of that and I have this much room for the bearing. They're like, yeah, throw away the smaller shaft. Like again, it's bearing. So again, right tool for the right job. So if you can decouple that stress, or in your load, that does not matter. For example, if you are working on a fan, pump, those things don't matter. Or your shaft, like your motor has one end of the bearing, the other is encased into something solid, and this is acting as a rigid body. Cool, awesome. But you have to be mindful of that. That's the one thing that I have to make sure that you guys understand. I've seen a lot of talks about this and all that, but like, dude, bearing, everything else is meaningless if bearing goes kaput. Like, thou shall have good bearing. And again, many times people overbuild a motor just so the bearing lasts. Look into basically teardowns of electric vehicle motor. They have amazing bearings. And again, that defines your lifespan. Almost everything else is similar. It's just that bearings. Quality bearings, good mounting of the bearings equals long lifespan. Failure to do so equals a very sloppy outcome. So this was a very unique company. I'm happy that somebody is trying to do something unique, and the fact that they are actually willing to work with the partners and it's like, okay, what do you want? Let's just tune something, not just like, okay, this is our motor, take it or leave it. No, they have the option. And not to mention, even if you have some other company, they will willingly sell you the motor driver also. So if you're like, hey, we already have a supplier for the machine part of it, what about the driver? They can provide the driver. So this is a good technology that I saw. But again, be mindful, right tool for the right job. So if you are planning to use that, be mindful where the heck you gonna mount the bearings, and what about the loads. Worst case scenario, do not take the best case scenario, worst case scenario, because again, bearings are consumable. They are consumed. Heck, I'm not joking, this happened. There was a shaded pole motor in my microwave. The fan gave out. Nothing was wrong with the motor. Shaded pole motor does not go bad. It's just the bearing of it, or not even bearing, bushing wore out. So I have to use WD-40 to fix it. So let that be very clear. Be mindful of it. Anyway, this was my short breakdown and explanation of Torus Axial Flux motor. I hope you guys have liked it, and I'll see you in the next video.